All right, today we are talking more about our exponential functions. And today we're going to be looking at tables like we did the last couple days, but we're actually going to write an equation for them. Today, all the tables are going to be exponential, so we don't have to figure out if it's linear, quadratic, or exponential. They're just going to be exponential. Okay, so this is what the equation for your exponential function looks like. So I just kind of want to explain a few things. So A is our initial value. It's also known as the y-intercept. And if you remember, all y-intercepts, they're on the y-axis, which means their x value is a 0. So all of the y-intercepts will be 0, some number. Okay, so A represents the initial value of the graph. It's also known as the y-intercept, and it will be 0, something. All right, B. This is lots of things I'm going to talk about. It is what the y's are multiplying by. So if I go back and I look at a previous lesson real quick. In this one right here, when the y's are multiplying by 4 every time, this 4 would be our b. Okay, and then where the x is a 0, the number that goes with it, the 1, would be the a. So 1 would be the a and 4 would be the b. And then I could write my equation, which I'm about to show you here in a little bit. All right, now B, more technically known, is the growth or decay factor. So B is our growth or our decay factor. We will know if something is growth if the b value is bigger than 0. We will know if something is decay if the b is somewhere between 0 and 1. Well, what kind of numbers are between 0 and 1? 1/2, 1/4, 1/8, 1/16, 2/3, 3/4. All those fractions and decimals, somewhere between 0 and 1. Okay, so today we're going to be looking at tables and we're going to figure out who the a is. It's going to be the initial value. It's going to be the y-intercept. So we're going to be looking for 0 in the x column. And then b is going to be what the y's are multiplying by. And we're going to talk a little bit also about growth and decay. Okay, so let's just get started here. So looking at this problem, can you find the a? A is the initial value. It's the y-intercept. So I look for 0 in the x column, and the 1 would be the a. So my a value here is a 1. So I'm going to have y equals 1. Now the b value is normally put in parentheses, and the x just stays in x. So now let's figure out the b. Can you tell me what these y's are multiplying by every time? The y's are multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So what they're multiplying by, that's your b. So our b is a 2. All right. So we talked a little bit up above. If your b value is bigger than 0, then it's growth. So this would be an example of exponential growth. And I'm just going to show you a picture real quick. There is the graphing calculator on our computer, but I'm just going to do it on my graphing calculator real quick so you can see it. So I'm going to type that equation in, 1 parentheses 2 raised to the x, so you can see what exponential growth looks like. And this is your typical exponential growth graph. So I'm just going to draw a little tiny sketch beside it so you can remember what it looks like. So it just goes something like this. So you don't have much of something at first, and then it just takes off and it grows really fast. Exponentially fast. All right, looking at the next one. Can you figure out who the A is? Remember, the A is your initial value. It's your y-intercept, so be looking for 0 in the x column. And here it is. So the A is the 400. So my A is a 400 here. So I'm going to have y equals, I'm going to put 400 where the A is, parentheses, I'll figure out Mr. B in a second, raised to the x. Now this one, can you figure out what they're multiplying by? So maybe you can tell they're dividing by 2, but what are they multiplying by? So I wanted to practice what happens when you can't real easily figure out what they're multiplying by. So if you can't tell what the y's are multiplying by, take the second y and divide by the one above it, and you get 0.5. Let's try it again. Take this y, 100, and divide by the one in front of it, or above it, and you get 0.5. Take that last y and divide by the one above it, and you get 0.5. So these guys are multiplying by 0.5, which is the same thing as, remember you can go math, enter, enter. So math, enter, enter. That's the same thing as 1/2. So I'm actually going to use the 1/2, but if you use 0.5, it's fine. All right, now let's see, growth or decay. So looking up here, if B is a number bigger than 0, it's growth. Well, 1/2 is not bigger than 0. 1/2 is somewhere between 0 and 1. So this is decay. So this is an example of exponential decay. So I want to show you what this picture looks like, because we're going to be looking at a lot of graphs in the next few days. All right, so let's look at this guy. So we've got 400 parentheses 1/2. I'm going to go ahead and put 0.5 just for easier purposes of graphing. Raised to the x, and let's hit graph. This is exponential decay. So it has a high value, and then it starts decreasing very rapidly, and then it slowly tapers off. So I'm going to just draw a little rough sketch of exponential decay. Starts up really high, decreases really fast, and then it tapers off a little bit at a time. I did not draw that very nice, but I am not an artiste. So exponential growth goes up from left to right. Exponential decay goes down from left to right. If your B is bigger than 1, it's growth. If your B is between 0 and 1, it's decay. Okay, let's try a few more. All right, so I'm telling you right now, these are all exponential. So we don't have to figure out if it is or if it isn't. They are. So first mission is to figure out our A. Because remember, we want to write our equation in the form y equals AB raised to the x. So do you see the A in the table? It's a 2. This is the y-intercept. So it's going to be y equals 2. Now we need to find our B. Can you tell what are the y's multiplying by the whole way through the chart? They're multiplying by 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And if you take 2/3 times 3, that's 2. Now, let's say you didn't know they were multiplying by 3. Okay, I'm going to show you what I showed you earlier. I'm going to just start with the 6. And I'm going to divide by the y above it, and I get 3. I'm going to take 18 and divide by the y above it, and I get 3. I'm going to take 54 and divide by the y above it, and I get 3. So they are multiplying by 3 every time, so that is our B. So do you think this is growth or decay? This is growth. If your B is bigger than 1, so if your B is bigger than 1, that's when you have growth. And just to remind you, if you were to look at a picture of this, it would go upwards from left to right. Shoo, it looks something like that. All right, let's look at this next guy. So our equation is going to be of the form y equals ab raised to the x. Do you know who the a is? It's 3. Here's our y-intercept. So my a is a 3. Now we just need to find Mr. B. So, can you tell what these y's are multiplying by? This one's trickier, isn't it? Okay, so let's take the 27 and divide by the 1 above it. 0.33333. Let's take 9 and divide by the 1 above it. 0.3333333. Let's take 3 and divide by the 1 above it. Okay, so that's what these are multiplying by. Let's make that a fraction. So math, enter, enter, boop, boop, and I get 1/3. So these are multiplying by 1/3 the whole way through the chart. So that's our B. So our B is 1/3. So 1/3, 0.33333, that is a number somewhere between 0 and 1. And if your B is a value somewhere between 0 and 1, then that is called decay. And if you were to look at a graph of decay, it would go downwards from left to right. So it'd start up really high and then taper off. Okay, and let's look at number 3 here. So y equals ab to the x. Have you found Mr. A? It's a 2. So y equals 2, parentheses for the b, get your x in there. Okay, and do you know who our b is? What are these y's multiplying by? They're multiplying by 4. And if you didn't know, you could go 8 divided by 2, 32 divided by 8, 128 divided by 32, but they're multiplying by 4. So are we looking at growth or decay? Growth. So anytime your b value is bigger than 1, which it is, because 4 is bigger than 1, we have growth. And remember those growth graphs, those go up from left to right, shoo, like that. Okay, so your task for me is to do number 4, 5, and 6, and you're going to do what I just did. You're going to write your equation of the form y equals ab to the x, and then you're going to tell me if it's growth or if it's decay. And then when you're done, take a picture of your work and post it to Canvas. And that's all for today. Smiley face.